Jeff Rowe from Two Hacks Garage. Well, I'm back in my garage, and this is one of those videos that's more of that what I call race engine nerd math. What's it have to do with? Well, it has to do with the correlation between your camshaft lift and your rocker arms. As we all know, that does play a big part in that, but how do you actually calculate that? Well, that's actually not as hard as you think, guys. I'm going to walk you through on how to calculate your actual gross valve lift based upon your rocker arm ratio and your cam lobe lift. This is not going to tell you what you need, how it's going to make more power or anything like that. I'm just going to take you through the basic steps, how to calculate your gross valve lift based upon your rocker arm ratio. All right, well, let's just start off by the basics. I'm sure everybody knows this, but this is a small block Chevy cylinder head. I don't have any rocker studs in here, but these are where your valves are at. And, well, you have a rocker arm that would sit on the studs here and a push rod that goes through that. So this is basically just a fulcrum. And it's designed pretty simple. So you got the bottom here where you would have, well, let me show you here. This one happens to be a stud mount. You got where your valve tip is sitting, and this is where your push rod is at. So it's pretty basic. Your push rod pushes this way, and that acts as a fulcrum, aka leverage down on the actual valve stem itself, and that's what moves it. So what is rocker ratio? It's the distance between the intake and exhaust valve and moving in relation actually to the push rod. So how does it actually have a ratio? Well, if you look here, there is a short side and a long side. That's how you get your ratio. The valve side of the rocker arm is longer than the push rod side. We're going to go show you a diagram here in a second. So what's that mean? Well, if you look here, right here, the center of that to here is shorter than that. So your push rod pushes here, and that's shorter distance than the center stud to the valve stem side. That's longer distance. That's actually how you get your ratio. I'm going to show you a second here, the math calculation on how to actually calculate that. Obviously, the higher the ratio, the more the valve will open. Changing ratio can actually also change your camshaft duration, but we're not going to go over to that. The reason I'm doing this video is this is going to play into importance on my rocker ratio because changing the ratio can actually cause piston to valve clearance issues, so you're always going to have to check that. We're not going to go over that. This is just the simple math on how to calculate your actual gross valve lift based upon the ratio of your rocker arms. You know what, guys? It's pretty simple. Rocker arm ratio is a multiplier of the cam lobe lift, which we'll go over in a second, and how that applies to the actual valve. Again, acts as a multiplier. So you know what, guys? What we're going to do is we're going to show you the math behind that and why it's important. All right. So I have my binder out. I take a lot of notes in here, draw stuff out, do a lot of math, that nerdy race engine math. You see here, I drew a diagram of an actual push or rocker arm, and I have the rocker arm we're going to use as an example for this. So if you look here, this is pretty easy. The math calculation is your rocker arm ratio is X divided by Y. Okay, so what is X, what is Y, and what are all these? Okay, well, your first part is your rocker stud pivot point, which if you look here, I'm going to set it up to orient it the same way, is where your stud mounts. So that's your pivot point right in the middle. 2, valve stem pivot point, which is right there, which is your roller tip. 3, push rod point, which is right there, number 3. Okay, so what do? Well, your Y, which is going to be your distance between the center of the rocker stud pivot point and the exact center of the valve stem, right there. This is the longer of the measurements. And you can see that right there to there is longer than that. Now, these need to be measured, which we're not going to do. I'm going to use a generic math calculation to show you how this all works. So your X calculation, exact distance of a rocker stud pivot point, 1, again, your center, and the center of the push rod point, 3, right there. That's the shorter of the two distances. The way that works, think of it as a fulcrum and leverage. When your push rod pushes this way to push down on the valve stem, if it's 1-to-1, it's no multiplier. You have to have a multiplier. So the longer side is the multiplier of the two. All right, so how does this all come into play? What you're going to need to do is use a pair of precision calipers to measure the exact center of this to the exact center of that. then the exact center of this to the exact center of that, like I laid out here. Exact center of your pivot point to your push rod point, pivot point to your valve stem point. You want to write those two numbers down, and I just showed you how to do that. You're going to put in your X and Y measurements of those two. Now, for sakes, just for easy math sakes, we're going to say those two came out like this. So let's say on Y, which is this part here, from your stud to your roller tip valve stem point equals 3 inches. Way off, I know, but we're just going to roll with this as for a math calculation. Now we measure pivot point, rocker stud, to your push rod point, number 3. Let's say that measurement comes out to being 2. So there's your two measurements. Y is 3 inches, X equals 2. So what you're going to do is you're going to take 3 divided by 2 equals 1.5. So your ratio is 1.5. So what does that tell you? Well, for every time that's pushing up on your actual cam lobe lift, you're going to take that lobe lift times 1.5. Now, the next part of this is assuming you know your lobe lift. If you don't know your lobe lift, guys, well, that's going to be another video where I show you how to use a cam checking tool, which is pretty neat. It goes into the actual lifter bores. You see a dial indicator there. And this tool can show you how to use or calculate lobe lift. Now, thing is, we're not going to show you that today because I don't have a camshaft installed in the engine. This will be another video. All right, so assuming you have your paperwork, which I'm going to have a representation of a cam that I'm going to be using. Okay, so right here, guys, printed this off. This is an Elgin camshaft that I have. It's the E901P. And when you look this up, it's rated as the Duntov 3030 cam. And when you look it up, they always say, you know, it's advertised as 485 on the intake, 485 on the exhaust. Okay, that is your gross lift based upon OE rocker ratio of 1.5. Now, the neat part about this is a lot of cam manufacturers will go off the OE rocker ratio, but that's not always the case, and I'll show you that here in a second. So if you have this number here, this obviously tells you with this, but if you don't have this, let's just pretend that doesn't exist, you can calculate your gross lift based upon your ratio. So let's just say you bought this cam and you have 1.6 ratio rockers. Well, that's not going to no longer be 485 or 485. Here's the important number right here. Intake lobe lift, exhaust lobe lift. That's actually the lift of the camshaft itself, okay? That is not the height of the lobe per se because you have to take into account of the base circle, but if you were to actually measure the lobe lift using a tool like this, you should get 0.323. You would not get 0.485. That right there is gross lift based upon a ratio of 1.50 of using those rocker ratios. So this is important to know. You need to know the exhaust and intake lobe lift. And it's always nice to know by your cam manufacturer. They're advertised, what they sell it as, lift on intake and exhaust. How are they calculating that? It's always important to know. All right, real quick, kind of an explainer why I'm doing this and why this can be important, but this is why in my case. If you look, these are a set of 461 casting small block Chevy heads. They've been machined, taking care of all of that fun jazz. However, I'm going to be running a domed piston in there, kind of a 2-valve relief domed piston. And the reason I am going through a lot of different math, and yes, I'm going to do the clay method to check everything, which will be another video, but just to be on the safe side, just trying to figure some stuff out, I'm getting all the calculations in order, and this is one of them, to kind of see where I'm at with piston to valve clearance. Because if you look right here, the amount of that ratio is going to move these valves out further. So when that pushes on there, at a higher ratio, the valve is going to come out further. Same thing in here, into that chamber, and I don't want it hitting into my pistons. That would be no bueno. So that's one of the reasons I am getting these numbers now. to me, it's less of a performance thing. It's more of a clearance thing. So with that, guys, what I'm going to do is show you how ratio is changing that actual valve lift based upon the rocker ratio. All right, so let's just assume, then this is like I said, this is the Elgin E901P Duntov 3030 cam. So advertise lift, not like the advertised lift at 50 or anything like that, but the marketing. If you look up this cam, it's telling you it's a 485, 45 intake and exhaust lift, gross lift, okay? And that is under the assumption with using the OE 1.5 ratio. So that's very important to know. The other important number, like we showed you on that paperwork, is your actual intake lobe lift, which is 0.323. So with my engine, I do know the rockers that I currently have for this that are on its way are a 1.5 ratio. So I know, and we're going to do a video with another tool to actually show you what the lift is going to be, but I already know the gross ratio of valve lift should be 485 to 485. Now, I'm still going to have to check my piston to valve clearance, but I do know that's the smallest one right now, the number that I have. But a very common performance upgrade on small block Chevys is a 1.6 ratio rocker arm and a 1.65 ratio rocker arm. So assuming I showed you the pretty technical detailed paperwork that had all the different numbers on there, but let's just say all you know is your actual valve gross lift based upon the OE rockers, how can you calculate that? Well, it's pretty simple. That's where your math comes in. That's where you take your ratio times your lobe lift on the cam, intake and exhaust, and figure that out. So let's just say my new lifters, if I was to get or rocker arm, sorry, to get the 1.6 ratio, mind you, these are the same on intake and exhaust, and that is not always the case. I'm going to show you here in a second. So I would take the 1.6 times 0.323, and my gross valve lift is 517. You can see that is a higher number than right there. So you're looking at 32 thousandths more. That could be a big player into my piston to valve clearance. Obviously, in some cases, the more lift you have, the more horsepower gain because of flow, but you also got to take into consideration of piston to valve clearance, especially running dome pistons. Now, mind you, this is just one of the numbers I'm going to get to calculate all that. We'll show those in other videos. But another performance option is the 1.65 ratio. So it's the same calculation, your rocker ratio times your actual lobe lift. So in this case, if I was to bump up to that, well, I'd be getting a 533 lift on intake and exhaust. So you can see that's quite a bit of difference from the advertised marketing of the Duntov 3030 of 485, 485. That right there could be the make or break deal of, whoops, I just slammed my valves into pistons versus maybe this or this. So that's why a lot of these numbers come into play. Now, you might ask, well, why don't they just go with a 1-to-1 ratio on these? Well, a lot of that has to do with the cam tunnel size. It's a certain diameter, and a lot of it is also the velocity of the lifter itself. That lifter is moving up and down. If it was 1-to-1, it would be so erratic and so, a lot of movement, and it probably wouldn't be good for the valve train. Another thing to consider when you're choosing your actual ratio rocker, the higher you increase your ratio, the faster it's going to open that valve. In some cases, if you go with too much lift, what can happen other than clearance issues with your piston to valve clearance, you could have valve float just opening up so much so fast, it could cause that. It can cause some valve trim issues. So just don't think that adding a lot of lift is going to add horsepower. There's a lot of other variables, which we're really not going to cover those in depth in this thing. But what I want to show you next is based upon Kyle's camshaft that he had in his 1968 Pontiac GTO. It was a 462 cubic inch engine, and it had a hydraulic roller. It was kind of a custom grind cam, and the thing about it is I looked at the paperwork on it, and I'm like, something doesn't seem exactly right. So I had to do some reverse math. Let me show you how I did that. This is another cool thing. All right, so I looked at Kyle's cam card, and this is a little bit different. So in that previous one, we knew the rocker ratio that they were using to come up with the lift, and we knew our lobe lift. Well, looking at Kyle's cam card for his comp cams, this is a comp hydraulic roller, part number 51-000-11. Okay. Now, it did not tell me the ratio they were coming up with, or the ratio they were using to come up with the intake and exhaust gross valve lift. Okay. But it did tell me the lobe lift on this. So it was telling me gross valve lift was 550 on intake and 546 on exhaust. Lobe lift was intake 367, exhaust 364. So how do you figure that out? Well, what you do is you take your gross valve lift divided by your lobe lift, and that's going to come up with your ratio. So when I did the intake and exhaust, I took the 550 from the gross that it was advertised at, divided by the lobe lift they were provided me with, and I came up with the 1.5 ratio, which, looking it up, is the OE Pontiac ratio. I did the same thing for exhaust, which is 546 gross divided by the 364 on the lobe lift, and also 1.50 ratio. So that's also stock. So they were using the stock Pontiac ratio to come up with those numbers. However, there's a caveat. This is not the actual gross lift of Kyle's cam that was in that. Why? Because we weren't using 1.50 ratio rockers. We're using the 1.65. So that's a multiplier. So this comes in handy, that calculation. So what is our actual lift? Because it didn't tell us, like the paperwork here on the other cam, if using different ratios. So the actual gross valve lift on the cam that Kyle had in his car was not the 550, 546. What you do, just like we just showed you on the small block Chevy example, you take your lobe lift times your ratio on your rocker to get your lift. So when I did the intake and exhaust, I did both calculations and came up with, on the intake, it was 610, and on the exhaust, it was 601. So this is about 60 thousandths more lift on intake and 55 thousandths more on exhaust. So right there, guys, real world example of the advertised marketing, if you want to call it lift of the cam, wasn't the actual gross valve lift. Take into account your rockers, and you're going to get your actual gross valve lift. Now, like I said, if you don't know your cam lobe lift, you can use different tools, and I'm going to show you how to use this in a future video to get that lobe lift number. And I'm also going to show you in a future video, if you don't know your rocker ratio, I know you can, like I said, measure it out, but how you can actually set it up and get that measured too. So yeah, this is another one of those, if you want to call it race math, nerd engine videos. I kind of like doing these because for me, this is going to come in handy when I go to build that small block Chevy. Just for, in fact, I'm using those dome pistons and I need to know piston to valve clearance. And like I said, there's a lot of other math calculations that's going to go into that. But yeah, guys, I hope you learned something with this. It's pretty simple to figure out what your valve lift is going to be based upon lobe lift and your rocker ratio. Till next time, 2 Hacks Garage. We'll see you soon.